Good evening, all, and welcome on this sixth session for 2024. Today's session is a talk on modern ports, function, and design aspects by Professor Nallayarasu, who is the head of the Department of Ocean Engineering, IIT Madras. We are privileged to have as our chief guest Dr. M.K. Ghosh, and the session will be chaired by Professor S.C. Misra. It's my privilege to introduce Dr. Ghosh to this audience. Professor Ghosh is the senior-most naval architect in India, still pursuing his profession, and he has been awarded the very deserving Lifetime Achievement Award by the Institution of Naval Architects. He did his BTech in IIT Kharagpur in 1957 and has a PhD in stress analysis from Bombay University. He had his shipbuilding training in Hamburg and training in ship safety and survey inspection in London and Newcastle upon Tyne and under government sponsorship. He has traveled to all the principal maritime countries, their shipyards and institutions during his professional career. In India, he worked in the areas of shipbuilding and ship design, ship safety, inspection, and naval architectural education. And at each of the aspects of his career, he reached the pinnacle as Chief Ship Surveyor in the Director General of Shipping, Government of India, Chief General Manager heading the Ship Division and reporting to Chairman at Garden Shipbuilders and Engineers at Government of India, Senior Professor and Head of Naval Architecture Division at IIT Madras. After his retirement, he has also worked for several years as the President and CEO of a filtration and environment industry in private sector. He has authored 7 books, of which one book, Sustainable Development, Environment, Energy and Water Resources, was published jointly by Anne Books and CRC Press. Welcome, sir. As the chief guest for this particular webinar. It's also my privilege to introduce the session chair, Dr. S.C. Misra. Professor Misra graduated with BTech Honors in Naval Architecture from IIT Kharagpur in 1970 and has his PhD from University of Newcastle upon Tyne in 1976. After a brief stint as a design engineer in Hindustan Shipyard at Visakhapatnam, he joined IIT Kharagpur as a faculty and retired as a professor in 2013. From 2009 to 2013, he was the first director of Indian Maritime University, Visakhapatnam campus. After retirement, he has been a visiting faculty at the IMU and Hindustan Institute of Maritime Technology, Chennai. He has served as the chairman of Naval Research Board, DRDO, New Delhi from 2016 to 2021. Currently, he is a member of the Board of Governors of National Institute of Ocean Technology, Chennai. In the past, he has been a member of the Technical Committee of Indian Register of Shipping, Mumbai, and member of the Indian Technical Committee of Class NK, Japan. He has been associated with design and construction of coastal research vessels for NIOT, passenger vessels for Andaman Islands, design of a feeder container vessel, and marine engineering laboratories in Indian marine engineering colleges. He has written 2 books as single author, Design Principles of Ships and Marine Structures, and Glorious Water Transport Heritage of Kalinga, Ancient to Recent Times. He has obtained the Distinguished Alumnus Award 2021 of IIT Kharagpur. He has also been conferred the Eminent Engineer Award in the Marine Engineering Division of the Institution of Engineers India in December 2022. In March 2024, he has been awarded a thank you citation for all-round contribution in the field of naval architecture by Institution of Naval Architects, Mumbai. He is also the founder president of the Technical Society Forum for River and Ocean Scientists and Technologists, FROST. Welcome, sir, and thanks for accepting our invitation to chair the session. It's also my privilege to now introduce Professor Nallayarasu, who is going to give the talk today. Professor Nallayarasu, a professor in the Department of Ocean Engineering, IIT Madras, has a total of 35 years of experience in port, harbor, and offshore industries, research, and teaching. Dr. Nallayarasu obtained his PhD from National University of Singapore, MTech from IIT Madras. Prior to joining IIT Madras, he had worked in Acre Solutions Singapore, a Norwegian firm, for about 12 years in various capacities, managing marine, coastal, and offshore projects. Currently, his research interests include interaction of floating and fixed structure with wave, current, and soil. He has published more than 75 research articles in refereed journals and conferences. About 28 scholars, MS and PhD, had graduated from IIT Madras under his guidance on various areas of research covering fixed and floating systems. Currently, he is the head of the department in the Ocean Engineering Department at IIT Madras. He has also actively collaborating with the industry to provide innovative solutions in the area of offshore oil and gas, port and harbor, bridging and reclamation, and coastal transportation. With the introduction of this chief guest, session chair, and the speaker, I now hand over the session to the session chair, Professor S. Misra. Please.
Good evening, everybody. It's indeed an honor to be on the same platform as Dr. Ghosh and Professor Nallayarasu. I must thank INA for having given me this honor. I am really pleased. The topic of today's session is modern ports. What does modern ports mean? Actually, in the last 15 years, technology has advanced so far that almost all fields have been changing drastically. It's not only technology, trade. Trade has also dimensions have changed over the world, and very much so in India. With water transport, we've given a big boost by the present government. We have ports which are big, having about 14 meters draft or more. We have medium-sized ports which have a draft of 8 or 9 meters, and we are planning to have a number of small ports for catering to coastal and river transportation. Talking about changes in the last 10-15 years, we are aware that not only trade has changed, but communication system has changed. We have had digitization and digitalization. Sustainability has become a big issue. It has changed almost all technical environments in the country, around the world. I'm sure Professor Nallayarasu will address some of these issues, and we're eagerly awaiting to hear him. Professor Nallayarasu, please.
Okay, thank you, Professor Misra, and thank you very much, Dr. Iyengar, for introducing myself and all the other chief guest and the panel chair. So I would like to thank all of you to give me this opportunity to talk to the naval architects of this country. And basically, I'm not sure why it was selected as a Saturday evening, but then everyone is at home. Looks like we are disturbing them, but then this will be a peaceful time where you don't get disturbance from office work. So it's good. So I'm going to make a brief idea about what's going on in the country and basically in the port and harbor sector. I've been involved in some of the major projects, some of the case study where, it will give us what kind of thought process. So I may start with my presentation if you say, Professor Misra, is okay to project the presentation.
Please go ahead.
Yeah, so I will start to. Is the presentation visible?
Yeah.
Okay. So basically, good evening to all of you, those who are listening in remote mode. I'm unable to see the faces, but I hope all of you are able to see the presentation. Today's talk is about modern ports, basically functional and design aspects, not so much into business or the other aspects, which also becomes part and parcel of development of a port. But today, what we are going to look at, what kind of outlook we are having in our country and what is important design aspects, which if you miss, what happens? Some of the practical examples I would give. So with that, we'll proceed to one small presentation on a case study for a recent project, which will give us some thought process. So I'm going to talk about the modern ports and its functions. And specifically, Dr. Iyengar has mentioned that breakwater design could be one of the area where it could give a little bit of insight. So 3-4 slides on how we do that kind of process. Then coastal shipping, one area, it has become, really a momentum. At least for the last 10 years, I have been working on various committees for the shipping ministry for, developing and improving coastal shipping. So I have just put a few thoughts on that. And then one case study, quickly I'll browse through one of the major projects which was inaugurated last month by our Honorable Prime Minister, which I happen to be part of the project in, brainstorming and developing the port. So that's where I will just complete my presentation. So to quickly go through the necessity and the early development of port and harbor in around the world in nutshell, I would say, why do we need ports is for initial areas like 1900, that kind of timeline, transfer of goods and services from all around the world where the population is, concentrated, especially river mouths, creeks, coastal areas, and mostly in the natural harbor where they try to, trade with each other. So most of the ports, if you look at ancient times, they are reasonably located in and around the cities where you will get natural shelter, landlocked areas or rivers and so on. But over a period of time, things have changed because the development of major ports is not becoming very easy to develop in these regions. Then we try to go away because there were considerations of sustainability and environmental issues, which makes development of ports near the cities becoming nearly impossible. So you will see most of the major ports getting shifted to slightly away. Of course, we cannot be very much away from the hubs of various facilities of services. So we need to be careful with the balance between environmental considerations as well as the necessity of connectivity and services. Typically, if you see this picture, which I have taken from one of the textbook earlier days, even now after hundreds of years, the British constructed ports or facilities for berthing ships made of various material. One of them is, even today we can see some of the old ports with stone masonry, and they are still operating after 100 years. You will see in Mumbai port, you will see in Calcutta, you will see in various old ports which stone masonry has been used as one of the material. Of course, today we don't need because we have better material than what they have been using. And timber and other composite materials which, mix and match was used in early days. But of course, with the technology what was available, they were able to develop ports for reasonable smaller water depth of 5 to 10 meters. That is a kind of range. You will see that today we have more than 20 meters as the depth available for docking largest vessel. In fact, I was involved in one of the project in Mumbai port, the first in the country with 20-meter dredge depth for docking large crude carrier. So today we have all this technology to construct, the facilities in deep water, or maybe we don't call them deep water, but at least more than 10 meters. So typically, I will just go through what happens to the restrictions in early trade time of 50s and 60s, where these channels have really played a major part in deciding what kind of port with respect to the vessel size, with respect to the draft required, have played a major role, especially in Suez Canal and Panama Canal, where the ships construction and trading really was depending on what kind of ships can ply through. Of course, one has a free travel of around the globe, but these are really playing a major role. So you just look at the marine traffic around the world, just giving you a picture of idea taken from that marinetraffic.com live. You can actually see live, but just I have taken one capture. Of course, it's exaggerated picture because it will be a tiny dot, but you can see the number of ships at any time, around the world moving in. You can see very seriously numbers of millions. So that means that many facilities around all the coastal areas are required for transferring cargo and passenger and other traffic. And specifically, if you look at our trade route, or we call it the main channel route, you will see that most of them going towards east to west and around the Indian peninsula, that we see that east coast is slightly less. West coast of our country has got a lot of vessels moving around the Middle East and the western side. And you will see that the trade traffic is generally this pattern. Of course, other coastal vessels will move in and around, which will also play a role in the development of any ports. So I'll just quickly go on to development of a port where we look at several parameters. One is the location, very important that the trade must survive and sustain, and also the volume and type of cargo, which is essential for the development of any port. And the type of cargo will decide on what type of vessels, what kind of water depth, and so on. And also some cases I have come across recent time that the selection of site also have to be linked to the design life, because the perennial effects of environmental consideration at that location makes it difficult to design because of the sea conditions. And of course, the right-hand side, what you see is the business case where you have to consider the various aspects of connectivity, siltation, dredging, capital cost, operating cost, maintenance cost. These are part and parcel of decision maker. Having decided a berth, you have to consider all these aspects, because ultimately the input versus output, what you spend and what you are able to get. And that finally the financial calculation decides whether any development of port will go through or not. Something that we must do this kind of calculations, which we call it the financial assessment, techno-economic assessment, or if you go specifically into it, the revenue and return, which is most critical in any business, of course, and in this business also very important. The cargo types, typically, if you look at any country, for that matter, we have goods, and goods can be classified into hazardous and clean. And also passenger service has become very much an essential part of the transfer now. If you look at some of the countries in Europe, they prefer water transport compared to the land transport. Of course, I have recently visited Europe. You will see that the number of passenger ships plying into inland waterways have considerably increased and gives us a very good opportunity to travel across without having to take a train or a flight. And of course, if you classify the trade into multi or international trade, primarily consists of POL products and containers, and of course coal and iron ore plus minus happening in the last 2 decades, but reasonably in an oscillatory mode. So you will see that the share of the trade makes us a little bit of sense that what type of port is to be built or to be taken into consideration while planning. Will have to decide what type of equipment, how we efficiently do it, especially with respect to cargo transfer, location of port, and environmental considerations. Because some of the vessels, for example, container vessel will require a lesser sea state, because during cargo transfer of container from land to ship to land, you need to have control of motion, which is essentially one of the important parameters. Many times people make mistake that a container can be lifted off anytime, because container vessel, very controlled motions are required. Otherwise, picking a container from ship is going to be one of the big challenge. So you will see that this picture I keep displaying into my classes because it gives us an interesting idea that the ships are not as small as what we think generally, because they are into water and very small height. But the lengthwise VLCC ships can be as big as the tower what you see. So globally, vessels have been built from various sizes since very early 40s and 50s into commercial trade and ships. Since I was practicing, I remember when I did the first jetty in Singapore, we were designing for 300-meter vessel, 320, something like this. Today, even 500-meter vessels are operating for container transport, which 24,000 TEU container vessel goes to that kind of length. So that is where you will see the growth of vessel sizes is becoming much more important, because the larger transportation, the efficiency of the system becomes better. And of course, you will clearly know that the per ton fuel efficiency becomes very much essential today, because the greenhouse effect as well as the environmental consideration, transporting too many small vessels is not going to work out. And that's where the ports are also gearing up for bigger and bigger kind of transformation of their ports. Older ports are getting upgraded, and the new ports are designed for future. In fact, in one of the projects we were talking, the the port itself is called the port of tomorrow. That means we need to think about what will happen over the next 10 to 20 years, have provision to, especially in terms of ship design and development. We need to consider what will happen. After 10 years, we should not end up, oh, okay, let us go and modernize the port again. So that's where we need to think about carefully. And of course, many occasions we hear about this particular aspect of design life many occasions, and I really would like to mention here, it's very important that what we are thinking about and what we are planning to actually invest, because the design life, selection of material, as well as the construction technique is going to be different if the design life is longer or shorter. In design engineers' mind, the longer it is, the exposure is higher. The larger the exposure, the design events become bigger, especially the natural events like storm, seismic, and the consideration of other like tsunami and related natural disasters. So you will see that the longer the duration of your life of the system required, you'll have to consider higher magnitude of design events, which many occasions I'm not seeing engineers taking into consideration this linking with that. Simply they go for standard process of design, which is not correct. And that's where we need to link something called the encounter. The encounter probability of a design event with the design life, which I used to mention about the exposure period by an example of walking across a street. Normally, how many times you walk across a road will tell you how much exposure you are against an accident crossing by a road vehicle. If it's one time or few times, maybe less. So that's where this encounter probability is a relationship between mathematically the longer period of life and the return period of environment, which we normally use it to connect between these. And most of the codes and standards around the country, around the world, they do give recommendations. But even today, we are using the encounter probability of typically, 22 to 30%. Whereas modern times, some of the projects that I'm involved in development, we are going towards 5% exceedance probability, which means the return period of a recurrence of interval from 100 years, we're supposed to be moving towards 1000 years or 500 years. Means the design event is going to be slightly longer, means the magnitude of event is higher. For example, design wave height, or a design storm wind, or a seismic condition, or even the tsunami or other cases will have to be taken accordingly, because 20 to 30% encounter probability means there is surely this event is going to happen, which is something that today no one is willing to take that risk, which is where most of the European codes have already transformed to 5% exceedance probability, whereas our IS code still in and around 39%, which is giving us a bit of worry, I would say. Because of that, most of the coastal projects built using that principle, invariably within the last 50 years, if you look at it, many of them got damaged because the probability of encounter of a design scenario is higher. Whereas if you go for 1000 years return period, the probability is lower. So even in case of an exceedance of a storm wind of 250 kilometer per hour, like what happened in Vizag, still will not damage. And in fact, that's one of the reasons where you see that the airport at Vizag, where the roof got just ripped off. It was not designed for an event where 250 kilometer per hour was, coming across at that time. So that's where things have to be relooked at it. Services like ports, services like airports, you can't afford to have roof ripped off, which is very much essential to keep them intact, even in case if such a condition exists. So this is something that we take into account in the recent times, that the selection of the return period of a particular event is very important to consider, that very, very carefully selecting the design event. I'll just quickly go on to modern ports. I think I have a little limited time, but of course, will try to cover up as much as possible. So the ports as a developmental into transfer of cargo, goods, services, you will see that natural harbor was one of the primary idea that ancient times people have selected a location where there is a shelter almost all around the year, wherein they do nothing, only basically build a transfer structure where we can berth the ship and have transfer of cargo. But of course, connecting to reasonable good highways for evacuating cargo, that is basically highways, railways, and so on, and also area for development of stacking yards, storage, as well as the transfer space. And of course, you may want to have additional protection against if it is in the river, there will be considerable amount of flow, which will actually start having movement of ships, which may not be very good for unloading or loading time. So you may have to construct protection, and that's what we call it. The sheltering effect from wave and current, and that's basically we go on to open sea. We call it breakwater. But if it is within the natural rivers or creeks, then it's just basically a bund wall. Of course, I will just try to put up a few ports where some of them I have visited, some of them I have worked, which is in fact the same slide which I showed it to some of the committee members during one of the project. The left side, the Singapore port, it's basically a Keppel terminal wherein some of the work was done. And Hong Kong, China, and Korea, Dubai, Rotterdam. In fact, recently I was there in this location. Basic idea was how they have come up with these facilities is actually not all of them will match with what we are looking at. Every one of them has got a specialized because of a different location associated with, and each one of them is different scenario. One is close to city, the other one is slightly far away. One of them is very close to open sea. But you will see that it's a cluster of facility for transfer of cargo and also storage, evacuation. Some of them are the import-export cargo. Some of them are transit cargo. They actually do have very little, for example, if you look at Singapore, is 100% transshipment cargo. Very, very little goes inside the country. Everything comes there and then they re-export. That means the business is very interesting model that if you have a port of the modern infrastructure with largest draft, very well sheltered, the largest ship can come there, offload the containers, offload the cargo, and then they can get distributed to smaller ports around the country, around the world. And that is basically the hub and spoke model, where you will be able to do a cargo transfer to minor ports or ports with lesser draft. And that's how most of the ports are surviving in today, because the internal necessity of import or export is very limited to each country. And that's where, our country also is gearing up into development of one or two major ports, which we'll speak about it a little later. Some of the projects that recently completed are some of them ongoing. You can see here, variety of challenges. When we are talking about open sea condition without breakwater, basically will have its own challenges of design, especially interacting with water. The bottommost one, which we see the largest oil berth or the cargo berth for transfer of crude oil, built in Mumbai, which I was part of the project where 20 meter is basically the dredge depth, 18.5 meter vessel can come, which is one of the biggest in that country, especially with within the Mumbai harbor, and various kinds of facilities like coastal cargo transfer, transshipment between two places using, containers with trucks, RoPax terminals, which was recently completed in Mumbai in JNPT. And similar project elsewhere, you will see that marine construction has actually evolved over a period of time. We'll just quickly browse through one idea about natural versus artificial harbor, Visakhapatnam, Mumbai. They do have outer harbor, but the inner harbor do not have any breakwater. So you can see the development of inner harbor in Vizag is one classical example that they have used the internal water body rather than going out. But of course, during expansion time, now we start going out, outer harbor 1, outer harbor 2, and so on. Similarly, if you look at the whole of Mumbai harbor, including JNPT and Mumbai port, there is no breakwater there. It's completely sheltered, especially the northern part. Of course, southern part still have some exposure to the wind and wave conditions during monsoon, but then not a great difficulty for larger vessels. Smaller crafts may not be able to operate. Whereas if you look at some of the east coast, like just an example of Chennai port or Ennur port or Gopalpur or elsewhere, you will see that mostly protruding, developments over a period of time, slowly starting. So you can see that yellow line, what you see is actually the natural coast. If you just go back in Google map, if you study, you will find that, the construction of these development have actually made a lot of changes to the coastal line in terms of accretion, in terms of erosion, in terms of accumulation of area where you see the beautiful Marina Beach on south of Chennai port is actually a result of the development of Chennai port projecting outwards, because there is so much of longshore transport of sand and sediments happening in the east coast from north to south during southwest and northeast monsoon, which is actually, you can see physically there, because we are going into the the obstruction of natural phenomena. In fact, in recent times, environmental clearance is becoming much more difficult if you have a shore connected breakwater. In fact, many cases we go with not a shore connected breakwater now, because this is what the result of what we see, and the densely populated city is getting eroded on the northern side. Of course, we have remedies now, but then do we need to do this? Typical port layout, I would just quickly get through what kind of ideas that we will require for an all-weather port or a seasonal port. The port can be classified into both. Sometimes we go for seasonal ports. Basically, we don't need throughout the year, but then the business model becomes very difficult. Whereas all-weather ports will have vessels coming and going in throughout the year without any, except maybe during the storm conditions or cyclonic conditions. And that's where you will have to look at your port development, including breakwater, which is very essential. So port entrance area for maneuvering the ships and basin and shelter against wave for protection for operation, and of course connecting through rail and road. So typically, if you look at all-weather port, design life should be selected at least minimum 50 years, and the waves inside should be restricted to less than half a meter. Of course, slightly higher if you look at other vessels, but most of the time we try to keep it to half a meter. 1 meter vessel, container vessel, sometimes large vessel can hold on, but smaller vessel may not be. And then, typically, what is the shelter or harbor? Harboring is nothing but trying to give a protection against the environmental conditions from natural wave and current. Typically, of course, wind you can't protect much. So we will have to design the ports where limit the wind conditions by which the operation can actually take place, or we will have to shut down in cases of very high wind during a cyclonic activity. So typically, you see the semicircular pattern is what adopted by designer, but not all the time this will happen, because depending on the coastal area, you may actually develop according to what is really in your hand. So you see the variety of patterns you can develop. The middle one I have just tried to show that you can also build the harbor within the landmass. In fact, if you go to Gopalpur port was developed on the basis of this pattern initially, but then it was not working out because large excavation. Then finally went out to the old model of trying to construct a breakwater outside. So, you will find plenty of choices, but then finally comes to decision making. We need to look at the aspect of environmental consideration and the cost. Now, if you look at these models, what we need is a sufficient area depending on what size of vessel. Now, if you look at a VLCC of 300 to 500 meters length, the ship has to come and maneuver, berth, deberth, means you need to have enough turning circle. And I think most of the naval architects will understand how difficult it is to maneuver a ship of large length. 300 meters, 400 meters is not going to be taking like our small car where we can turn to any direction. And that's going to be one of the area where we need to have sufficient space, 3 to 4 times, 5 times of ship length will be the radius that we require to turn around. And of course, every port will have that area, and then there will be difficulties in trying to actually bring the ship to the berth, because then you can't have 100% turning near the berth itself, which will be controlled by tugs. Typically, we do this kind of assessment using maneuverability study. There are several techniques, manual or track plot or simulations, 2D, 3D, desktop, all kinds of studies we make for the entry and exit of the ship. In fact, some of the ports which you see similar to any other transport hub on land, you can see entrance and exit is different compared to the single entrance to the port. Many cases, very narrow channel become accident prone. In fact, some of the congested ports, we do experience in the recent times collisions, which is very much avoidable by having, of course, separate entry and exit. So the typical port access from one end, then exit other side, having berthing area fully sheltered on both sides, sea side and land side. You see the logic. The larger water depth can get from the sea side of the berths. Smaller water depth can be taken here, and kind of arrangement division into cargo. One side is clean cargo, the other side is hazardous cargo, one side is passenger. So some kind of common sense thinking can be made, which does not really require too much of, I would say, ocean engineering. It's just a bifurcation to make the operation safe and sustainable without much of the hazard. So typically, we do prepare ourselves, especially on the right-hand side, you see we did some project with the Ennur port. It's already fully matured port, but developing any new one, we need to take into account the operations of, the other existing terminals. And the left side was one of the greenfield port where it was done in, I think in one of the country in Africa where we were trying to develop a new one. So you will see that every one of them, we need to assess the width of approach channel, making sure that consideration for wind and crosswind effects when the ship is coming and berthing and deberthing and going out without having any implications on existing other facilities is very important. So the maneuverability study is part and parcel of any port development. We normally use the starting point is simulation, but then later on we go on to a 3D simulator to make sure that the captain can berth and deberth, and what is the necessity of tugs. In every project we try to make what is the capacity required for tugs, what kind of maneuverable situation, high wind should be tried. In fact, even with this modern technology, even now we do have drifting of ships hitting this berth. In fact, 3-4 years back, one of the accident at one of the port in Mumbai, the container vessel straight head on 90 degrees to the berth line and hit and punctured the structure 3 meters inside. And I was looking at the remedial. It was such a high impact that it was able to rupture through 2-meter depth beam and in fact 0.5 meter slab 3 meters into it. So that is the kind of situation where we will get in case of uncontrolled movement due to wind, or of course mechanical failure is something different, but environmental consideration always can be prevented by doing necessary remedial activities, including the high capacity bollard pull tugs, which can control the movement of the ships near the berthing structures, which is nowadays becoming very essential. The other aspect also needs to be thought about is, in fact, very important to have the consideration for tidal range, because the vessels becoming too big a range will be a potential problem. In fact, if you see here, single fendering arrangement of berthing ship with one single vessel is easy. But what happens if the vessels are smaller in nature, tidal range is bigger, then we'll end up putting fendering system to accommodate all types of vessels, all type of tidal range. So we have to come up with such kind of ideas. Otherwise, what will happen? The ships will go underneath, and it may damage the berth or jetty, which is becoming very important today. Also, the control of velocity, which I think most of the naval architects will be able to understand, the higher velocity vessel moving towards structure. It's not advisable because it may damage. So you see there is less than half a meter per second is the kind of velocity that we normally permit when they approach. But then less than 10 centimeter, 20 centimeter per second is a kind of velocity you can make a first point of contact. And how to control. So that means the ship has to have assistance from tugboats. Probably main engine is off, trying to bring down closer. But even otherwise, we also have the system which we were working. In fact, 25 years back, one of the project in Singapore, we did this particular interesting technology. Basically 2 laser beams will be pointed towards the ship, and the reflected laser will be received by a laser meter at the jetty, and a display of a large size with the green, yellow, and red signal will display the velocity and give an alarm. So when the vessel is trying to come closer, so if the velocity is higher, then actually the captain can either do some remedial or go back. So this is what we call it berthing height system. Today they call it velocity of approach system. But this is I remember it was one of the first one in Singapore itself in 2000. We started with this particular because accidents do happen in that time, very much congested area. So this kind of latest technology could be utilized. In fact, the number of ports operating in our country, I don't think any of them are using, except the one just recently I recommended in JNPT, where a container berth, I recommended that this must be installed because they were trying to do multiple berthing of 2 vessels at one single berth in a single line. So this is one of the area where restricting movement of the vessels and also warning the captains, making sure that they are aware of what speed they are approaching to avoid accidents is very interesting, not very expensive. And of course, systems for, olden days bollards may not work now because we need to know what is the kind of loads onto the mooring ropes, onto the pits and bollards on the ship, onto the cargo transfer. So the complete monitoring system with fully instrumented mooring hooks, we call it, is complete display of everything what is happening with vessel movement, vessel trim and roll and pitch, as well as the loads on the mooring line itself can be displayed on a panel in the control room, where we can actually see everything before taking a necessary action, either to remove the vessel or disengage the vessel, or disengaging from remotely. In case of fire, if we are not able to go to the ship, or if we are not able to communicate from a remote, we can release the ship, and the ship captain can take an action to release, because captain cannot come down here. So when he wants to take the vessel away from the berth, because there is a fire on this jetty, then of course we need to have this so-called remote release system. It is now becoming mandatory. Basically, the PESO guidelines and the industry requirements that every hazardous cargo like oil, gas, we need to have this kind of system involved. Most of the berths are in fact now installed with this, because otherwise the government guidelines does not give you permission to operate. So that's one mandatory system that we look for nowadays. And of course, as part of our study, we normally make wave tranquility or wave penetration or wave diffraction study. You see here, this picture gives you an idea that how much is the pink color versus the blue color. The blue color is a lower magnitude of wave inside, and basically means the constructed shelter or a harbor, so-called breakwater, is giving us that kind of protection against the incoming wave, which is what the essential part of selection of site and selection of the kind of protection by building a breakwater. So that's something that every project we try to make. This is where ocean engineers are involved. We need to come up with this study to make sure that the penetrating waves inside is limited in height. And of course, less than half a meter is some kind of norm that we normally adapt. And some cases we go up to 0.75 meter or 1 meter in case of large vessels. The last topic is the coastal shipping. Not the last topic, the second topic. I hope, Dr. Iyengar, I have another 10 minutes.
Yes, sir. Session chair can decide on the times.
Yeah. So basically, I was involved in some of the discussions at the committee set up for Maritime 2047 and several committees we have discussed about the coastal cargo. I just wanted to give some little feedback on what we have been doing and developing. So you see here, there are three areas where we have identified. One is Gulf of Kutch, other one is Gulf of Cambay, and of course, inland waterways. The interesting aspect of land transport versus coastal cargo transport, honorable ministers earlier and now in the central government were very keen to develop coastal development. This is one of the presentation I made at that time. Basically development of cargo transfer by means of ro-ro pads, especially larger ports like Mumbai will have large containers coming in. But when the distribution by land versus distribution by other means, railways, or by ships themselves into the trucks going in will be one of the very interesting aspect. The time and the cost saving, you see the green color versus the sea route, a lot of savings. Of course, I'm right now working on few of the projects right now ongoing, and furthermore development should be happening in times to come. I think 2030, we should be having number of such facilities. Transfer of cargoes would become by RoPax. Similarly, if you look at Gulf of Kutch, we also have a lot of plans to develop several inland waterways, the coastal shipping areas where the avoidance of such large roadway or land route is to be taken into account. For such kind of facilities, we call the facility development depends on the tidal range. So in that particular report, when we were doing, we were classifying the whole country into 3 or 4 important zones. And of course, the most critical one is in the western part of the country where the tidal range is very high. Eastern part is not so difficult because the tidal range is much less depending on the coastal exposure. So you will see that zone 5 and 6 and 7 is the tidal range is typically from 8 to 10 meter, which you will see that managing a port with 8 to 10 meter tidal change every cycle is really going to be a very tough job, because the ships will go through that. If you are unloading for 2 hours, is okay. But if you are unloading for 2 days, the ship would go up and down several times in the tidal cycle. And your fendering system, your unloading system, your other facilities should be capable of taking into account the tidal range, which is one of the biggest problem. So we need to decide upon what type of facilities will be suitable, fixed type or floating type or semi-floating type. In the report we had elaborate, but I won't go into much details. The tidal range makes one of the important aspect of design of such facility. So for example, in one of the facility which we have built is basically using a floating pontoon, and the pontoon will try to make arrangement with the interface with the ship, where it will provide facilities for transfer of cargo with a span of bridge linking the floating facility and the fixed facility, which is what we call it the RoPax facility or RoRo facility, where you will be able to transfer cargo all the time without having to worry what the tide is, because the interface is kept constant, because the floating itself is supporting the ship. So the cargo will move through whatever be the tidal range, it will move through. This is one of the picture which I think I have shown earlier, which is becoming almost a standard now. Everywhere we are building this. So with that, I would move on to quick on to the breakwater. I hope I'm okay with another 5-10 minutes. So yes. So breakwater is part and parcel of both development. In early days, when I was a civil engineer, when I was working in the company, we used to design, breakwater with rocks of sizes, smaller breakwater. but nowadays becoming larger, deeper water depth and bigger wave heights. So the artificial armor, what you see on the right-hand side, taken from some of the suppliers and vendors, concrete armor units becoming very essential because we are designing for the largest wave heights, largest height, largest water depth. It's becoming very difficult to get bigger size rocks. So we move on to artificial armor units. So what is a breakwater? Breakwater is a barrier trying to take the energy of wave coming from sea and do work. That means a deformable structure with the deformation within limit. If you build a rigid structure, then it would have to be transferred to the sea bed by means of the structure design, which is going to become very difficult. If you have to design for breaking wave loads, it's becoming very, very tough. That's where the rubble mount structures or breakwater made of stones and armor units becoming very, very common. Typically, a breakwater would be something like this, a bund type of structure where you will see that the rock is dumped and protected by the armor or the layer of material which would otherwise take the energy of the sea wave trying to come and impact on it. That's what we call it, the armor. Armor can be stone or can be materials like concrete, man-made, of size that required to take the energy. Of course, the inner bund is made of normally rock, not using other material like soil, because construction becomes not possible. So mostly a typical breakwater will be of this kind. Of course, the protection near the toe is required in case of damage due to scouring or other slope failure. Will be able to protect it on the seaside. And land side, normally not necessary to worry because it's anyway waves are smaller. So the most vulnerable area is here where the waves are interacting with the stones. So typically, breakwaters of variety of types have been investigated by researchers, professionals, but then still we go with rubble mount breakwater as cost effective, sustainable, and of course not very good in terms of environmental consideration because you are going to break a big hill. But of course, whatever be the construction, we still need material of construction like even if you go with the other material. So basically, you will see that rock breakwaters, caisson type breakwaters is nothing but make a RCC caisson and just keep them one around, but then normally not done in many cases. And of course, recent time, a lot of people are studying piled breakwaters, different types of breakwaters, but cost effectiveness and design becomes really difficult. So I have in fact done one case study, finally come to a conclusion that even today, rubble mount breakwater will be the best choice given the situation with respect to cost and efficiency. So typically we need to come up with the dimensions, which is a design problem, which I think if you follow certain boards and standards, we can fix the width, slope, stability, selection of rock and selection of thicknesses, all this part and parcel. But typically, 1 in 1.5 to 1 in 2 is the slope that will be naturally stable using the natural materials like rock and armor units. Of course, one important aspect I would like to highlight is the dimension I have put is RC. Many times people make mistake. I would spend 1 minute on this particular aspect. The lower the height of the breakwater, the amount of water spill over to the port side becomes more, especially during storm condition, especially during cyclonic condition. That means there is potential damage of the port side, means stability in question, the whole breakwater will get washed away. And that height is higher means cost is higher. So many times we do a lot of trial and error by study, experiments in laboratory, experiments, medium scale, and then finally we fix because that's going to decide our cost. And basically, the failure of that will be failure of the port because none of the operations within the port can take place. So typically failure can be a slope, failure can be overtopping, failure can be at the toe. Of course, toe protection can be made substantially stronger. And basically overtopping will be increasing the height. Now, if you look at overtopping, we are going to study, by laboratory, in Pune, we have our Central Water Power Research Station, CWPRS. They have been doing a lot of studies. Of course, we also do at IIT Madras, this kind of measurements. In the recent times, we have a laboratory developed for that kind of studies. But model study versus real is going to be some difference because of the scale effects. But then we rely on both empirical formulas given by several researchers. Basically, the guidelines given for limiting water discharge on the port side for various functions for pedestrian, vehicle, safety. But for the stability of the breakwaters, what is really required, not really mentioned by these codes and standards, which is what you will see in some of the pictures which I would give you. This is one project where it was constructed in 2021, 22. And then I was a passerby as a visitor. And I just was mentioning that the crust height is lower, may have a problem. But then nobody believed that it is actually going to happen. But in 3 months' time, it actually happened. So you can see here, waves are surging, waves are breaking, and waves are reasonably breaking and a lot of damage done. Some of the videos, if you just see, you will see that waves from seaside is passing across. You can see at this location, is splashing, which is becoming potentially, the height is lower, which is something that very, very important to say that the design is kind of problem. We should not have a breakwater designed in such a way so much of water is splashing onto the other side. You see this picture. This is something that we have to think about. And that's what we were talking about. What should be the height that will make us make sure that this side is protected, because this side is protected because this side is taking the energy. Something that I want all of you to understand, that design, there is nothing free. Your brilliance does not come with all necessary protection because you have reduced the height. The reduced height will come to this kind of effects. So that's where sometimes we call it value engineering, optimization, fit for purpose. Finally, one of the days becomes like this. Potentially rebuilding this will become double the cost of the project, which is something that happens. So with that, I think most of the main presentation is over. I would just like to highlight a quick review of one of the projects where we recently planned and designed and completed, which will give us a kind of idea what goes through a major mega project development, maybe 10 slides, I think. So I will proceed. So basically, this is one of the project which is there for last 10 to 15 years for development, but slowly now it has picked up the pace. It's called Vadhavan Port. You might have heard in the recent newspaper times last 6 months to 1 year. The investment is approximately 76,000 crore, and the water depth or the dredge depth or the draft, we can bring in vessels of this 18 meter to 18.5 meter, and large breakwater of 10 kilometer. Initial plan of constructing a terminal of this kind was there in the planning, and during the process of finalization, I was involved, and we had a lot of thought process together with the officials, together with the government authorities, and we tried to see. And in fact, my advice was this will not work because you will have to transfer the cargo, the containers from the berth to the stacking yard, back and forth 5 kilometers. This manner is not going to work. And, this is never a design that will be adapted in elsewhere in the world. So this approach of original case versus the final, if you look at it, it is, completely different. And this is the area where there's container stack yard, railway yard, connecting to road. So all necessary requirements have been made, but then except the cargo comes here and then transfer here, stack and transfer to inland or goes out again, which is what the plan. So we had, in fact, I prepared several cases. I'll just browse through in two minutes. The case 1A was shifting the container stackyard near the port or near the berth, where the container movement becomes limited to the locations specific to the berth. And of course, you can keep your railway yard and other facilities up here with a very single link where things can become transferred easily. And that was the original plan 1A. And basically, the second plan was to shift even the railway and every facility near the port and just connect only by a single connectivity where the landside facilities can be located. So this was the second option, almost similar to the terminal that we have seen in Singapore, almost similar type of ideas. And then there were sub ideas of various other minor features. And basically, we were deliberating for almost 6 months. And finally, we selected one of the options that would be economically good, and also implementation becomes a little bit of faster. So there were some 5-6 cases we were coming up with, summarizing, and finally we made one selection based on this kind of selection matrix. Normally we apply in industry, where we look at similar to any merits of the project or demerits of the project, where we try to put down value for money. How much is actually going to give us? So this is what we call it, the matrix of evaluation. So we see that option 1C, where everything is moved towards the near the port with the highest mark, which gives us an opportunity to select among the 7 options studied. We try and make such kind of development something similar 1C. And this is what finally finalized and went for budget approval, cabinet approval, and PIB approval. And finally now inauguration of foundation stone has happened. So this project is going to be one of the game changer for us, because you might have heard ministers and officials talking about this port will be equal to the country. Basically what it means, today we are handling about 22 million TEU cargo of containers, and this one single port will be able to handle the same quantity. Of course, time to come, another 10 years. So basically this will become one of the major hub serving the region and the country into a mega development of marine transport. And I hope the information I have provided would have given you some usefulness. Thank you very much for listening to me. Thank you. That's all, Dr. Iyengar and Professor Misra.
Yeah, Professor Misra, I think your microphone may be on mute. Right?
Professor Misra is muted. Professor Misra
Yeah.
may switch on the mic, sir. You are muted.
Okay. All right.
Yes.
I was hoping that if we should hear Dr. Ghosh first and
Yes.
then go for question and answer.
Yes.
It's an excellent lecture, Dr. Nallayarasu.
Thank you. Thank
Anyway, may I request Dr. Ghosh to give his address?
Dr. Ghosh, your microphone is also on mute, sir.
you. Yes.
Okay.
Sir, your mic is you are muted.
Misra, can you hear me properly?
Yeah,
Yes.
now we can hear you.
Well, this is a paper in much details, and paper contains 80% engineering and 20% other infrastructure. One first point I would present as the design life. Other port, you said it will take 10 years to build. So what is the design life of that port? Minimum design life of a port should be over 100. Today is very capital intensive. The minimum life would be 100 years basics, but preferably 200 years. That is one point. Other point, let's emphasize the depth of water in the design. As you know, the container ships are all very large ships, and most of the future cargo will be carried on the container ships only. So they require depth, breadth, movement. So dredging is a very important point. If missed, Gardner shipbuilders at one time had a high expertise in deep dredging, suction dredging. So this is a very important technology which is required for the building our newest ports. The other point is the size of a coastline. We have a coastline of 7,500 kilometers. And country is planning expansion in the Viksit Bharat Plan 2047, 5 times growth in the economy. So we require a lot of ports spread over the 7,500 kilometers of line. So possibly we should have a port or a cluster of port every 100 kilometers. Another point, perhaps a modern concept, a port need not be a single harbor. A port can be a cluster of a harbor. China doing that one. The Shanghai, near Shanghai, the port area, plan area is 200 kilometers. One single port is a cluster. So that is a kind of a mammoth projects they have there, and we have to go to it. Your presentation is very detailed and very good, but this concept for our future needs of the India, you know, what size of the ports, how many ports, this planning is very important. The teamwork, I don't know whether there is a central body planning the ports of the whole of India. Go. Compared to Sagarmala, we have the roadways. Similarly, for the water transport, we require another Mala concept, where we are generating cargoes, export cargo and import cargo. Need not be same place. There are these two separate concepts, where particularly your tankers, inward cargo in the India, tanker port will be the inward cargo. Whereas your Bombay or Visakhapatnam, there with the containers there will be outbound cargo, because we want to emphasize the exports. So these are the few things I would broadly say, but by and large, I'm not very much in touch, though I try to keep it, but my age does not allow me to do it. I'm very impressed with your talk, Professor Nallayarasu, but you have to expand the concept. We have to build up a school of designers of the ports for India. And you have to collect merits from the all progressive ports. You have to attract merits from there, and you have to build a school of port designers. This is very important. Thank you very much. And my thanks to Dr. Iyengar, Dr. Kurula, Professor Misra is a very brilliant naval architect from my institute where I graduated. And Madras, of course, is a fantastic IIT. The way they're expanding all their research activities, systems research, Madras is very high. The system research concept has to be injected into the port design also. Thank you very much. This is what I will say.
Thank you.
Thank you, sir. It was excellent hearing you. Can we have the question answers now? Professor
Yes, sir.
Nallayarasu, will you do all right if we can go ahead to question answer?
Yeah, sure.
Yeah, I think the first question is from Professor Ajit Shinoy from UK. He writes, my thanks to Professor Nallayarasu for a most interesting and informative talk covering a good spread of port and harbor design and construction. The technical and physical aspects of the ports were explained in detail. Professor Nallayarasu did allude to the importance of intermodal connectivity at each port. That effectiveness of the road and rail connectivities and the speed of materials handling in ports do have a great impact on the efficiency of ship port operation. Please, could Professor Nallayarasu outline how these factors have been taken into account? Thanks.
So, I didn't get too much into the multimodal transport. In fact, Government of India has taken a very big initiative with respect to existing ports and the new ports. Basically, connecting all modes of transport to the existing port and vice versa to the other transfer is very essential, because when a particular cargo is reaching certain location, unable to reach either to the outbound or to inbound, the evacuation becomes very difficult to digest, because the business model does not allow you to expand. So that's where the road connectivity today, if you look at it, every new port that we are building, for example, the port that we were mentioning, a dedicated rail corridor, DFCC, basically freight corridor is made in such a way that the cargo seamlessly is able to transfer from the port to inland or hinterland, or from hinterland comes to the port without much of stagnation or delay. In fact, every project, when we do re-evaluation, for example, an existing port, if we want to modernize, the first thing that we look at is the road connectivity and the evacuation of cargo. Because when you improve your efficiency of the port, it does not mean that the port is going to operate at that efficiency level, unless you are able to take the cargo and reach to the final location where it's supposed to go. So the connectivity, especially in our country, it's slowly improving, but of course, it will take its own time. I think government for the last 10 years have taken a lot of initiative. In fact, there is a project itself for developing master plan for connectivity to ports, which every port is supposed to prepare a plan and submit. So I hope this will become better and not a bottleneck. In fact, some of the existing mature ports like Chennai and Calcutta, evacuation of cargo is really, really troublesome, because going through the city is not very easy. I hope that answers what he was talking or asking about.
There is a question from
Professor Ajit Shinoy is also added to the panel, sir. He can perhaps comment, sir. He's also added to the panel.
Sorry?
Professor Ajit Shinoy is also in the panel, sir. If he wants to.
You say something?
You would like to add something, Professor Shinoy?
No, I think it was very aptly answered. I just wanted to highlight that there are physical aspects of port design, the civil engineering aspects, which are very important. But ultimately, the success of a port is how quickly the cargo that comes to the port reaches the end customer. So it is not just clearing the port, but also getting through the road or the rail and ultimately reaching wherever that cargo is meant to reach. So somewhere in the equation, I think the port designers have to take this also into account. That was my main point, and I think Professor Nallayarasu answered that way. Thank you.
Mr.
Thank
Naresh,
you, Professor.
he has asked, sir, where on Indian coast can we get the deepest water? He also has another question, so I'll read both the questions. What type of fenders are good for the jetty? Vertical fixed fenders or elliptical Yokohama type fenders? Professor Nallayarasu, please.
Okay, so I think it's a good question on design aspects. Basically, fender. You have fixed type fender, which I think I have shown in the picture. The fender is fixed to the structure. The reason fender is required because the ship with its kinetic energy, when it is first point of contact, the impact force is so large because the mass of the ship is so large. So the energy is to be absorbed by compression of the rubber. Now, if the location is such that the center of impact and the rubber fender is in together, then it is good. If the fender is down and the ship mass is at high due to your tidal range, then the fender will not be effective. There will be more forces coming to the structure, and structure has to be designed. That means it will become expensive. So Yokohama fender versus fixed fender, very clear. The answer is very simple. If the tidal range is smaller, then you go for a fixed fender. If the tidal range is very large, like Gulf of Kutch, Gulf of Cambay, then you have no choice, because 8 meter, 9 meter tidal range, you need to have the fender moving with the water. So always there is a contact between the ship and the structure. So that's where you will see in Dahej or the ports in and around Gulf of Cambay, you will see the large size Yokohama fenders or equivalent fenders of similar type. Not necessary that Yokohama should be used, because there are several arrangements can be made. But mostly Yokohama fenders of floating type will be used in tidal movements, not in the fixed berths where the tidal range is 3 to 4 meters. We are able to manage the cell fenders of circular shape with the frame at the front. So I hope this answers your question.
Mr. Chug, is it okay?
Yes, sir. It is very good answer. I was in ABG shipyard, and then we debated this issue for months and months, and we could not arrive at good solution.
Right.
But his reply is very clear.
Thank you.
sir.
Thank you, Naresh.
We have a question from Mr. Ashok Kumar Pandey. Thanks for this presentation. With mechanical failures in container vessels on the increase, how do port structures, standards in piling, slabs, etc., likely to be affected in future design plans?
Okay, so this is a multitude of answers required, but of course, mechanical failure of a ship is definitely not considered as a primary design factor in any port design. Very important to understand. In civil engineering, at least, or ocean engineering, we can't design for such kind of scenario. For example, as aircraft failure or a failure of a ship or a failure of a machinery is considered as out of design event. So it does happen, of course. So the example I was talking about, in fact, I wanted to put the picture. The container ship punched through the structure 3 meters inside because it was hitting at a location where the fender is not there. Fenders are spaced at, say, every 10 meter or 15 meter, but the ship came and the bow directly hit the RC structure. The only way is to put fenders everywhere. Is it a practical? For example, if I have a 1 kilometer of quayside where the ship is coming and berthing, if I want 100% protection against any possible mechanical failure and drifting of the ship and hitting into structure, then I have to put fender everywhere, which will become practically not possible because you will never know where it's going to hit. So that's where such kind of scenarios are not considered in design. As it comes, we face it. But if there is a considerable possibility of a drifting vessel comes and hits a berth, then we always can construct a separate provision for protection against drifting vessel. For example, some of the projects I remember crucial structures where it is expected, especially like someone from ABG shipyard was talking, in that region, we have even considered a protection structure against ships coming and hitting. Means during launching or during maneuvering, but not a regular port we design for direct impact of ships due to mechanical failure. For sure, it will become very uneconomical. So I hope, Ashok Kumar, you understand it's not possible.
Okay, thank you, sir. And my question was actually more on that bridge type of accident which has taken place, but this similar incident with a smaller maneuvering speed that occurs in harbor could also impact the jetty and other structures, offshore structures.
Right.
So it was in that respect, ships also lose power, not only just because of mechanical, sometimes electrical failure completely brings down the vessel. It becomes absolutely unmaneuverable in the harbor itself at times. It may revive power after a short while, but then these incidents are happening and sometimes affect the port operation. That's why.
Thank you.
We have a question from Mr. Krishna Kotak of J.M. Baxi and Company. Sir, what is likely to be the rate and quantity of siltation and dredging of Port of Vadwan after completion, please?
Okay, so this is an interesting question, which I know why the question is coming, but I think is very, very important to understand every port. We evaluate this. This question is, I think, probably related to some business proposals. There is siltation, but of course, it is within the parameters of evaluation. I don't think I want to give you this information because the tenders are going to come out very soon. So I hope you understand.
Mr. Kotak, is it okay?
Yes, absolutely. I understand. Although what is important to know, like a Mumbai port or any of the other ports where the level of siltation can also determine what is the size of ships that eventually can conveniently come, is what I think eventually will be important to decide.
Yeah, actually, I think CWPRS have done a wonderful job on that particular siltation aspect. We find that the breakwater arrangement, what finally are aligned, is not having any impact on considerable reduction in dredge depth during 1 year. So the maintenance dredging requirement is considerably lower.
Understood. Thank you.
Thank you.
There is a question from Arvind Sharma, who would like to get an idea of how the design of the port takes into consideration power requirement. We have a lot of ports in EU, USA, and China now connecting to shore grid, giving an ecological dividend. Yeah. But these, of course, do end
supply possible.
Some power supply possible.
That is not POI at sports, I think. So because
Mr. Sharma, can you read your question yourself?
Lots
Sharma,
of ports. He is not able to speak, I think.
Okay. Professor Nallayarasu, can you answer this question?
Yeah. I understood the question. Actually, it's a very interesting question. When the ship is in the port during unloading or loading operations or waiting operations, considerable fuel economy, especially the power required to keep the ship up, on port side. Basically, mostly in the olden days generated in the ship. Even now mostly the European countries and China, they have been providing shore power. So as soon as the ship arrives at the port, they can connect to shore power so that the main power generation systems inside the ship can reduce. And that's something that was not provisioned in the earlier days of old ports, old berths. Now, one by one, all the major ports are actually transforming themselves by providing shore power connection. So the moment the ship comes on berth side, they can connect. In fact, if you look at, I have been working with naval projects, considerable number of projects in and around our country. Every naval project, we provide this shore power connection. Because most of the ships, they want to have that connection. The moment it comes there, they will connect it. So this is going to be a long process because the old ports, there is, the converting them into shore power connection becomes really difficult because they are already old. You have to make a provision, socket, bring the power. It's not very easy, but it's happening one by one. So new ports, always we now give a provision for shore power connection to the ships, correspondingly estimate the load, electrical load required and select the power requirements and then provision in the initial stage. Some of the old ports may not have even the supply itself because they have planned for a very, very old system. So that's something that is becoming problem.
Mr. Sharma, is it okay?
He is not able to answer or speak.
Maybe his mic is off.
Something like that, yes.
Anyway, we'll sorry about that. Jyotisman Dasgupta. There is a comment from him. Hearty congratulations to Professor Nallayarasu for an excellent presentation. I would like to elucidate two aspects relevant for NS. One, there is a requirement on the speed on a passing vessel, depending on the size and distance from the stationary moored vessel inside the harbor. Two, the design of the mooring system and the fendering system needs to be optimized to ensure that neither of them take the extra load during limiting storm conditions. May I request Professor to please clarify this, sir. Thank you very much.
Okay, so it's an interesting aspect, especially question number one is a very, very interesting question, especially applicable to mature ports like, say, take an example of Mumbai port, having two major ports. Mumbai Harbor, I would say, Mumbai Port, Jain Port. The traffic in and around the channel, the main channel from open sea entering into the harbor itself is very busy. And this aspect of passing vessel, I think is technically sound question. The one vessel is stationary at particular port or particular berth and the vessel going just nearby, crossing and moving towards another place, which we call it the passing vessel. I think most of the naval architects would also understand that there is an interaction between two floating bodies. This is basically an idea. But in this particular case, one vessel is stationary, moved with the jetty, another vessel is going. Now imagine, the hydrodynamic fluid impacted forces going to the moored vessel, vice versa, is basically changing the scenario for the mooring system. In fact, an accident has happened at several ports where a passing vessel is going very high, generating ripples of waves and underwater, fluid motion, causing the moored vessel to drift and move, break the mooring line. This is what has happened in several places. So the one that I have shown in one of the picture, we did investigate for the first time in the country that mooring system design, including passing vessel on the neighboring vicinity within the channel area. And we find that the increase in mooring loads is almost 15 to 20% due to the passing vessel effect. If you have designed for a particular wind of 10 meters per second and waves and the mooring is already designed. And when a vessel is moving close by and the mooring forces are increasing by 10 to 20%, that means either the mooring wire will break or the structure will fail. And this is where now it has become mandatory that any jetty or a berth very close to the channel or somewhere in the vicinity, you have to take this into account. And I think last 10 years, my research scholars and some of my students, we have done a lot of research on this, conducting experiments, numerical models, finding that there is a relation between the speed of the vessel, the distance between the moored vessel to the moving vessel. These two parameters, and of course the size of the vessel, will affect considerably the mooring system of the moored vessel. You can actually Google my name, you will get a lot of published papers giving some guidelines on how much will be the effect and what kind of magnitude. So that's the point number one. Point number two, the design of mooring system and fendering system that needs to be optimized to ensure neither of them take the extra load during limiting storm condition. So it's an interesting question that we debate even today as a risk assessment. In fact, this question I do ask our students after the class. Do you expect a ship to be alongside of a berth during cyclone? No, you cannot and you should not. You should actually take the ship away from the berth, because during cyclone and heavy weather conditions, the ship goes through large motions, which we cannot design neither the mooring system in the vessel nor the mooring system on the structure or the mooring line itself. So all of them will fail, and that is the experience that we see, that in large vessels or vessels moored during a tsunami, during a heavy wind wave conditions, would have actually got damaged themselves. So during storm condition, it is better that we move the vessel away from the fixed structure. Of course, if you have a mooring structure in the open sea condition, like a mooring, spread mooring, maybe okay, because it is not going to entangle with any structure at all. So I hope you understand the situation that always during storm condition, evacuate the vessel from the berth itself, unless the berth itself is fully protected, that waves are not going to come there. Of course, wind is still going to come. So I hope you understand, Dasgupta, that the real practice is don't keep large vessels near the jetty when a stormy weather is coming.
Thank you very much, sir, for clarifying it very well.
Yes.
The second thing is, only issue is sometimes when you're having an FSRU or an FLNG, then we need to have it stationary despite the storm condition.
Yes.
And it cannot be just taken away. So in that kind of a situation, what do we do, sir?
I understood this is a subject matter of very much, it's ongoing on every project. Of course, it depends on the design of the project. If a project has got, we call it double banking design, one side is LNG vessel, the other side is your FSRU. FSRU is going to be stationary during 100% of time. Disconnecting them will be the last resort that you make. So basically, yes, if you take any of our West Coast, we have got 2-3 LNG terminals where FSRU is on one side and LNG vessel is transferring LNG. But there are situations where the FSRU has to be taken away. That decision to be made after assessing the port tranquility and the mooring system design, because the last thing that you want is the bollards and structures fail, because that will damage the structure permanently. So FSRU, if necessary, it has to be moved. I would want to give one example that we did a elaborate study in Mumbai Port, Mumbai Harbour, where FSRU was coming and I was consultant for them. And there was a classical case where the FSRU was moved against the jetty because it was a sheltered area. But then when we looked at the motion response during monsoon time, it was entangling with the jetty structure and the fender. And it was advised that if the FSRU is a spread moored system with a quick release hook, at the seabed would be a better choice than mooring with the jetty, because anytime if you want to move away, the vessel can be disconnected and taken off.
Right.
So ultimately, the project did not go through for several other reasons, but final design was 2 connections to the fixed structure, 2 connections to the seabed using a quick disconnector. And in case of storm, it can be removed. And one important thing is, one more case needs to be considered in case of emerging situation of external threat. Especially in the Mumbai Harbour area, you want to remove and take away your FSRU because it's a large inventory of LNG. So in such case, quick removal is very essential for consideration. So that's where, sometimes we consider disconnecting system type LNG vessel for FSRU, not just a fixed type.
Yes. Thank you very much. So thank you so much. Thank you.
There is a question from Mr. P.R. Govil. Calcutta is a riverine port and enjoys special status due to excessive siltation. Continuous maintenance dredging is carried out by DCI. Siltation can be reduced by river training and bundling. Government is spending a lot of money in maintenance dredging of ports.
Yes.
I don't know. I suppose he's asking your comments.
Yeah, basically, the word I liked it, enjoy special status due to excessive siltation is an interesting, statement itself. But of course, one has to pay the price of, nature. We can't bypass the nature. Of course, we wanted to get into riverine port because we don't need to worry about waves. In fact, some crosstalk is coming. Okay, so in fact, I am actually recently working with Haldia Dock Complex for an LNG terminal just about 4 kilometers from the mouth of the river, and we find that waves are not there. In fact, I find that the very tranquil condition. But of course, siltation, current is something that you can't avoid. River training. In fact, with Calcutta Port, one of our colleague, Professor Murali, is working with them for quite some time on siltation, dredging, and related aspects. But I don't think with the kind of several multi connections to the main river, river training could considerably reduce the siltation. It will still bring, during monsoon period, considerable amount of silt. So, as I mentioned, to some extent, we can challenge the nature, but remaining we have to follow. So I think siltation 100% reduction cannot be made in such kind of locations, and we have to continue to dredge. Of course, by providing one idea called silt trap. Normally we think about this, particular location, we make a trap where the silt can come and deposit there. You can consider that location as a dredging spot rather than dredging everywhere. But then evaluation of cost and time is something that works out carefully for a particular scenario. So I hope this answers your question,
Mr.
Govil.
Mr. Govil, are you there?
Thanks. I'm here. Thank you very much.
Okay.
That's very good.
But your question is interesting, wording.
Yeah. I know. Look, I was working with the Ministry of Shipping, so I knew the internet of this Calcutta port.
Right.
Thank you. Thank you, Professor.
There is a comment from Mr. Arvind Sharma, who had asked the previous question, one of the previous questions. Thank you. So can I conclude that all new ports in India will be equipped to provide shore power to ships at berth? Sorry, not being able to unmute myself.
Okay. And the answer is yes, of course. In fact, it is now mandatory that we have to provide shore power, because most of this we call it sustainable as well as green shipping, green ports. We are trying to provide this power connection to all new ports. Old ports, of course, it takes its own time to implement because of the limitations, because of physical infrastructure. Because, for example, if you have to provide shore power connection to some 10 berths, you require so many megawatts. From where it will come? Because the substation which was built in 1980s there is no enough power. So you have to bring in main grid power, substation, supply lines, and installation of the sockets. Oh, it takes a lot of time. But new ports, yes, definitely it's going to happen, and it will be definitely implemented.
There is a question from one Mr. Chandan Maiti. Thank you, Professor Nallayarasu, sir, for this very informative presentation. I have a small query that the turning circle radius of ships have a significant impact on the size of the harbor. I would like to inquire if there are any modern methodologies or research going on to reduce the turning circle radius, especially in ports and harbor design.
Okay. Basically, there are typical guideline in open sea maneuver versus maneuvering in sheltered area. See, two things. If you see the ship maneuvering, all naval architects sitting across the country, you will see that engine power turning is one of the important aspects in the free running model. But inside a port, you will be doing maneuvering using tuck assistance in a slower speed. But definitely not less than 3 times or 2.5 times the ship length, because physically you will not have unless you do the reversing of the ship, which is not going to be very easy. Because, for example, if you have to take a 90-degree turn without doing reverse, it's not possible. So that's where, today the mandatory requirements of, 2 to 3 LOA will be the turning radius, at least required even with the tuck assistance. If you want to have a engine power to run, you need even much more higher. So that's where a lot of course, optimization is being done. But after one accident only, you will realize, no, this port is a dangerous one. So we still have a mandatory requirements of 3 or 2.5 or, at least in that kind of number, but not less than that. And of course, that much space is required for taking you to various parts of the port, because if you have very narrow, then it will become like a log gate, not a port. Is that okay, Maiti?
Mr. Maiti, are you there? Can you unmute yourself and say if it's okay, answer?
Okay.
Okay. I suppose it is okay with him. Is there any other question from the audience or?
So there are some feedbacks in the chat also, if you want to take a couple of them.
Yeah, sure. This has come, Ullas Kalga. Hearty congratulations to Professor L. S. Nallayarasu for excellent presentation on an entirely new topic. That's okay. Then we have Vipul Garg. Sir, I am presently working in a Pune-based company. We are going to develop a shipyard and a port terminal on the west coast of India. Please suggest a team of professionals to carry out a feasibility study and DPR.
You can contact later on, no issue.
No, he continues. His course, no, that's it.
Yeah.
He can please contact Professor Nallayarasu separately. Then we have.
I think that's all.
That's all.
Yeah.
That's all. So is there any question from the people who have been listening? Is there anybody who can raise hand and we can entertain the question?
Anybody from the panelists, sir? You could ask the panelist if anybody would like to come in for comments. Sir, Manu here.
Yes.
Sir, your comments, sir. Your comments, sir.
Yeah. Actually, we are fortunate today. We have Professor Nallayarasu, who has given a wonderful talk on port and harbor. It's a new topic. I really thank you, sir. Actually, there will be a lot of queries. Actually, a lot of queries were coming to us about port and harbors. And so this definitely will be coming in. And about Dr. Ghosh, I don't know whether sir remembers me or not. Sir, I was also there at Garden Shipbuilders and Engineers, and we are all proud of you. He has designed a bulk carrier, not now, 40 years back. Totally indigenous design. Not only design, he has constructed it, made it, and number of them. And we are proud of you, sir, ever proud of you. And then, of course, Professor Misra, is, he had been my professor as well. So I am so happy. He is going to conduct a conference next month. On actually, so inland water transport. I hope, while he concluding remarks, definitely I am sure he will be talking about that as well. I'm, really happy that, sir, you have come and our lecture program. Actually, this program, Dr. Bharadwaj Srinivasan is hosting every month. And we have got some of the best speakers speaking about it. And we'll be really happy, sir, in case if you, once in a while come up with new topics for us like this and in-depth new topics. Now over to Professor Misra.
Yeah. Thank you, Manu. Thank you. I should say Dr. Manu Kurula. Thank you very much. And now I have to conclude the session. First of all, my sincere thanks to Professor Nallayarasu on talking about ports. Modern ports, he meant actually new ports as well as modernizing old ports. Am I correct? Yes. I think both of you have addressed. And it was an excellent speech in the sense that he has covered almost all aspects of port design and port operations effect on design. We had a lot of discussion on how big the turning area should be. It was interesting to hear so many people have asked questions and they have got answers. Professor Nallayarasu has talked about various aspects of design. He has talked about natural harbors, sheltered harbors, and harbors with breakwater, which give shelter, shelter area for ships. It's very interesting that there are some sheltered areas where you don't need to have a breakwater and it's open to sea and you can berth your ship and come out. I have always wondered that if in olden times, all harbors, ports were made on river mouths, why is it that we are going away from the river mouths today? Perhaps a brief answer has been given in the lecture by Professor Nallayarasu. I understand that. But then there is a question when you have breakwaters, there is some siltation or some erosion on either side of the breakwater. And if it is Marina Beach of Madras, which has been substantially extended because of erosion, is very nice. But it could also happen the other way, where there could be some erosion of the beach on some other place. So these are some of the issues. I'm sure the port designers will be taking all this into account. He has mentioned to us about big ships coming in, big oil tankers. And in this connection, he has mentioned also large container ships, and he has given the example in the Vadhavan port. I have always wondered, you make 76,000 crores of investment in one port. What happens if tomorrow the trade fails? Trade changes, like it happened in early 80s, 1980s, with the oil transport, when more or less a lot of European companies went bankrupt. I don't know what would happen if we invest so much of money and make such a big port. And also another issue comes here. Has anybody done a return on investment? How many years it would take for 76,000 crores to be realized? Here, Professor Ghosh has mentioned about a port existing between 100 to 200 years. That's so. That's correct. But in 100 years, can we get back that money? I'm sure that the DPR must be talking about this. It would be interesting to know that. Then Dr. Nallayarasu has also talked about layouts, and particularly very interestingly, he has shown that circular layout, which I did not know about it beforehand, and it's very interesting. What attracted me is use of sensors. He mentioned about use of sensors in mooring systems, in tracking the vessels coming into the port, the speeds, and all kinds of technical data to be available to the port authorities based on sensors. And this is really very nice, very nice. I don't know if any port is really doing this, but if they could be doing it, perhaps we can have a much better operation, safer operation for ships in ports. He has talked this monitoring systems. Then he has talked about coastal shipping. He has mentioned about large ships coming in, big ships, tankers, container ships in big ports. He has talked about spoke and hub system of container transportation. He has talked about medium-sized ports. He has also talked about coastal ports. And we have had some good discussion regarding intermodal connectivity and port operation and its success. It was very interesting. Then he has given us a good background of breakwaters and their design. The three types of design he has mentioned about piled breakwaters, rock breakwaters, and pontoon breakwaters. It's very nice. I mean, everything has been covered in this lecture. But in this breakwater system, I don't know why he hasn't mentioned about floating breakwaters. There is also a system of floating breakwaters, particularly in smaller ports and this thing. And if I remember correctly, there was some work in IIT Madras some years back regarding generating power from the hollow breakwaters with water entry. I don't know whether it is still going on, it has succeeded, or it has been discarded. I'm not aware of this. Anyway, it was very interesting hearing all this. And particularly, I was also impressed with the valuation chart that has been prepared. Is that called a valuation chart? Validation, validation matrix. That's very interesting. Is it done for all ports, Dr. Nallayarasu? Perhaps it is done for all ports.
It's a evaluation, that kind of comparative evaluation is a must. Because what happens if you don't do this and you select one particular concept, proceed with the project, halfway through the project, one new official will come. Did you do this evaluation of others? Then the project will take a U-turn. So this is where the DPR should contain merits, demerits, quantitative evaluation, not qualitative. So that, you can actually present, this is the case evaluated and this is the case selected. This is essential.
That is very, very nice. And we had very interesting questions for this talk, and it was indeed very interesting. Thank you, Dr. Nallayarasu. And I would also like to give my thanks to Professor Ghosh, Dr. Ghosh, who has been kind enough to come. I know his conditions, and that he came and he gave us his views was really very, very exciting to me. Thank you, Dr. Ghosh. And
Misra.
Yeah.
Thank you. Very good. Your analysis was as comprehensive as the original paper of Professor Nallayarasu. Both of them enlist us with your knowledge and your power of analysis.
Thank you very much. Thank you, sir.
Thank you. Thank you.
And I would now thank Dr. Manu Korula, the president of INA, and Dr. Bharadwaj, technical secretary of INA, and Mr. Amir Ahmad, and all other people, including Selvi, who have been involved in organizing this webinar. Let's say call it a seminar. And thank you all. Thank you. Thank you very much.
Thank you.
Thank you, sir. Thank you, sir.
Yeah.
In fact,
you have to give a vote of thanks. Sorry.
It's okay, sir. We already done
What
it.
are things?
You already thanked everybody, but on behalf of INA, again, I would. It's very nice of Dr. Ghosh to have joined us. In fact, I was actually hesitant for the same reasons that you told whether he'd be able to join us. It was very, very nice to hear his views on this particular topic. And thanks to you, sir, for chairing the session. It's my duty to thank on behalf of INA. Thanks to you for chairing the session. Very efficiently, the Q&A was moderated and your summing up was excellent. As Dr. Ghosh told, both the lecture and the summing up was measuring up to each other. And thanks to Professor Nallayarasu for the excellent lecture, sir. You covered a lot as told by our session chair. It was indeed very instructive and informative. And for naval attacks also, we had a lot to take from this lecture also. It's not just an informative lecture, but also we had a lot to take from this lecture in terms of turning cycles and many other naval tactical aspects, maneuvering aspects, turning cycle aspects, and many other naval aspects, which was very nice to know that. And also, we had an attendance of around 30 as registered attendance, and I know the attendance is more because one of the attendance was Ocean Engineering Seminar Hall. I'm sure that there will be a number of students who are sitting in the Seminar Hall of Ocean Engineering Department of IT Madras. So the actual attendance count is more than 30, but we had 30 registered attendance.
I made them to sit there and project it in the screen.
Yes. So that is obviously more than 30 have listened to this lecture. Thanks to all the people who have attended the lecture. And
Bharadwaj, actually, there are people at Cochin University and IIT Delhi.
Yes, sir.
So they are also sitting in a hall. At least, definitely more than 100 participants have attended today's lecture program.
That is great because this lecture is really very informative for the students.
Yes.
And also my thanks to Professor Shenoy, Mr. Chuk, Mr. Dasgupta, Mr. Sharma, and all the people who made the question answer session interesting, and a lot of points came from the question answer session also. We thank to all the people who actually participated.
Some of the questions are very interesting, I tell you. Some of the questions are really interesting.
Thank you all for joining on a Saturday evening. Thanks and
okay, good evening.
On to the evening, sir. On to the evening. Good
night. One more second. I just wanted to say, actually, since the last lecture program, actually we have got some of our naval architecture friends. We really, our condolences to the family. And one is Commander Nilendra Nigam, and the other one is Sri Vinay Kumar Singh. On behalf of INA and all of you, I convey this to the family, our condolences, and we really feel bad that we have lost these wonderful people. Thank you, Bharadwaj. Bharadwaj, please go ahead.
Can I give a message outside the seminar? Can I give a message outside the seminar?
Yes, we'll do that. We'll do that.
Okay. Yeah. Just for information of the audience and INA, my conference is being held at Bhubaneswar on 18th and 19th of October, and the topic is green technologies in coastal and inland water transportation. We have got a lot of papers, and I think some of the papers are very interesting. We will be hosting this in the website also, and that website I'll pass on to INA, and that can be distributed to all the people who are interested in listening to the various talks. The program also will be there. Even the students and others can choose the topic they want to hear, and I'll do that. Thank you.
Thank you. So hopefully some of us will be physically available in Bhubaneswar.
Of course. You have to be there.
Yes. Not only me, I'm just telling for the general audience of INA.
Yeah.
They're always welcome to join live at Bhubaneswar also.
Okay.
Yes.
Okay, thank you.
Thank you.
Thank you. Now it's becoming good night.
Thank you, Professor Nallayarasu.
Yes.
And good night, Dr. Ghosh.
Thank you also. Thank you all.